So at the top of your notes, if you would change it to say 14-5. We already did 14-4. 14-5. This is the last new lesson before you take a test over what we've gone over. And I know that you guys have been on spring break, so tomorrow we're going to do a review over everything. All right, who can tell me what is Pythagorean theorem and why do we use it? What shape do we use it for? What kind of triangles? Only used for right triangles. And if you guys remember, there was a mathematician named Pythagoras, and he was playing with squares. And what he figured out is if you put two small squares together and then a third bigger square, if it forms a right triangle, then the area of the two smaller squares will add up to equal the area of the bigger square. And so that is what Pythagorean theorem is. Okay, so we use Pythagorean theorem to figure out if a triangle is a right triangle, and we use it to find the length if there's a missing side of a right triangle. All right, so let's go look at what we're supposed to know. It is important that you know that the two sides of the right triangle that form the right angle are called legs. Y'all need to draw a little right angle right there. They are called legs. The side across from that is called the what? Hypotenuse. And what side is that? A, B, or C? This has to be the C. And then this can be your A and B. And does it matter if you switch those around? No. The side across from the right angle has to be the C. All right, so now that you know which sides are your A, B, and C, you can simply plug these numbers into your formula to solve for a missing side. So everybody look at this example. Which side is the C, the 3, the 4, or the missing side? How do you know that? Because what is right here? A right angle. So that has to be your side C. And then you can simply plug in these numbers to the Pythagorean theorem formula. So everybody write the formula down. A squared plus B squared equals C squared. And this is on your star chart. Okay, which side do y'all want to call A and which one do y'all want to call B? Okay, 3A and 4B. So I'm going to do 3 squared plus 4 squared equals C squared. Am I going to add or am I going to subtract? When you're solving for C, you simply add. So you're going to put in your calculator 3 squared plus 4 squared. And what's my last step of Pythagorean theorem to get rid of this square? Square root your answer. And the square root of 25 is 5. Are y'all remembering this? Okay, if you flip to the back, this time, what side is missing? A or B, right? Because this has to be the C. So we'll call this A and this B. The most important part of Pythagorean theorem is that you label the sides correctly. Write your formula and plug in the numbers. I don't know A, but I know B is 12, so 12 squared equals 13 squared. Would I add or would I subtract? Why are you going to subtract? Because you cannot add. Does that make sense? So anytime you're solving for A or B, you're going to subtract. the bigger one, 13 squared minus 12 squared. And the answer is 25. And how do I get rid of that square? What's my last step? Square root. The square root of 25 is 5. And that's just a coincidence that they both had the same answer. Okay, is everybody good with solving for a missing side? Yes or no? Now, what else can we do with Pythagorean theorem? The next thing we can do with Pythagorean theorem is say if it is a right triangle or if it isn't. So everybody look at the 4 examples at the bottom of the page. Look at example 1. Is it missing a side? So I wouldn't use Pythagorean theorem in this example to solve for a missing side because there's not a missing side. But what I could do is use Pythagorean theorem to say, yes, that's a right triangle, or no, that's not a right triangle. Are we all good? Yes or no? All right, so how would I use Pythagorean theorem? I would say, is a squared plus b squared equal to c squared? And I would say, yes, it's true, or no, it's not true. So which one of these numbers would have to be the c? The 7. So I would say, is 3 squared plus 4 squared equal to 7 squared? Do y'all see that I'm not solving for anything? All I'm going to do is write yes or no. So you're not going to use your square root button on these. You're simply going to type this in and this in and see if they give you the same answer. So type in 3 squared plus 4 squared. And then type in 7 squared. Did they give me the same answer? Yes or no? No. So they gave me 25 is equal to 49, and we know that is not true. So this would not form a right triangle. So let me ask y'all, are you going to use your square root button for these? No, because you're not solving for a missing side. All right, set example 2 up on your own. Which one did you make? It has to be the C. The 50, because it's the biggest number. Okay, this is how you should have set it up. You type in 30 squared plus 40 squared. What'd you get? 2,500. And then you type in 50 squared, and what did you get? Do those equal each other? So yes, 2,500 equals 2,500. That would form a right triangle. So my answer to that one would be yes. It is a right triangle. Okay, try the next one. Which one of these would have to be the C if it was a right triangle? So is 6 squared plus 8 squared equal to 10 squared? So I type this in. Did y'all get 100 equals 100? So what's your answer? Yes. Now this last one is one that they put on the STAR test, and I have shown you this before, but I just want to make sure y'all remember. Remember that if you put 3 squares together, it will form a triangle, right? To see if it's a right triangle, you're going to do the exact same thing that you did here, but what's the only difference? Does anybody remember? What does this one say? What does this one say? But what does this one say? Centimeters squared. So what does that mean? They already squared this one. So if you want them to all look the same, you could simply square root that. What's the square root of 100? 10. So if I square root 100, look, it's 10. So if you want them to all look the same, simply make sure that they all just say centimeters or inches. If they say inches squared, that means it's already squared. Well, didn't we just do this problem right here? So I would say, is 6 squared plus 8 squared equal to 10 squared? Which the answer would be yes, because 100 equals 100. So what do you do if it already has a square on it? You can simply square root it to get it back to that side length. That means that's the area of that square. All right, I'm going to pass out the assignment. We'll flip through it and make sure everybody's good. Remember at the top to change it to say 14-5 instead of 14-4. Okay, remember that if you have a triangle with a missing side, then you're using it to solve. But everybody look at number 1, and we've talked about this. Does this 3 belong to that triangle? Does that 3 belong to this triangle? It does not. What does belong to that triangle? The 6 and the... So could I just cover that up so it doesn't confuse me? Now, which side is the C? This side. So go label, that's my C. And what do y'all want the 6 to be? It doesn't matter, right? A or B? I'm going to make it B. Okay, so I can solve for A by doing Pythagorean Theorem. So I do A squared plus B squared equals C squared. Everybody's writing? Would I add or would I subtract? Subtract 10 squared minus 6 squared, which I believe is 64, but y'all tell me if I'm wrong. And what would I do to this answer? Square root it. And the square root of 64 is 8. But that's not my answer. 8 is the height of the yellow part of the triangle. This right here is 8. So I just changed that A to an 8 since I solved it. But they want the height all the way down. So why did they give me this 3 over here? They want the height from here all the way down. Well, what do I know? I know that from here to here it's 8. But what's this piece right here? That's where the 3 comes in. 8 plus 3 is 11. So anytime they give you an extra number, you're just going to probably add that back into your problem. If it's not part of the triangle, just hide it until the end. Okay, please remember over here, the 2 smaller squares add up to equal the... But y'all remember fact families, right? So I could say the big square minus one of the smaller squares will give me the other square. Okay? All right. Let's see if there's anything else that's tricky in here. Oh, look at number 4. If I plot point Q at 5, 6, remember that this is the X, this is the Y, so I go to 5, go up 6. There's my point. And I translate it 10 left. That means count 10 to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then go 8 down. 1, 2, 3, 4, 5, 6, 7, 8. It wants to know the distance between those 2 points. Do y'all remember on our star chart, we wrote down the word distance by Pythagorean theorem? Do y'all remember that? So what would I draw out of these 2 dots? A right triangle. So you drop a line straight down even. And that should have been a straight line, but it's okay. And I can count this side. It's 8 and 10. And I can use the Pythagorean theorem to solve for my missing side, C. Y'all remember this, right? Okay, and then number 5 and 6 are just like the ones on the back of your notes, where you have to find the one that is a right triangle or isn't. Number 7, you're simply going to take your 25 and add it back into your answer, so just cover it up so that it doesn't bother you until the end. And I think that's it. Y'all should be able to do the rest on your own. It's very easy. It's all Pythagorean theorem. Come check your answers with me, and then you will post them in the Google Classroom.